In this lecture, we'll understand what is the central theme of big data. I would say this is very, very important from the perspective of learning big data. And also, if you understand the central theme of the big data, more or less the topics in the future loop back to this particular topic. Let us see what are the central themes of the big data. Any idea? Can you just think of what may be the central theme of the big data based on your intuition? Pause the video and just think. They are distributed storage and distributed processing. Based on knowledge we have gained throughout our career, central theme of the big data is distributed storage and distributed processing. What is distributed storage? What is distributed processing? Let's see that. Assuming that you have a big file of 1 GB that will have a table. So we just left this table blank so that you can fill the data on your phone, right? This 1 GB of a file which is containing this particular table having around 5 attributes is stored in one system. But what happens is, for some reason, the capacity of this system may not be able to store 1 GB because it has already stored a lot of data. So the next thing what we can do is take this 1 GB of data and distribute across different systems, like these 3 systems. So what are the data which were supposed to store in this particular system? Split that and store that around 300 MB in this particular system, around 424 MB in this particular system, and around 300 MB in another system. What we are trying to do here is we are distributing the storage of the data. What are the file we had 1 GB file, we split that into smaller chunks and we are storing that in these 3 tables. So as against storing the data in the same system, we are trying to split this large amount of data, that is 1 GB of file, into smaller chunks. If you look at the way we are storing, for example, if you have a big table, some of the records as a part of the 300 MB will be stored as a part of this system. Some of the records will be stored as a part of this system, and some of the other records are stored as a part of this particular system. So splitting of the data happens like this. This is in a way is a distributed storage. We are taking a single large file and splitting that and storing in a different systems which are connected over a network. This is a distributed storage. Now that we understood distributed storage, let us try to understand distributed processing. If you really look at the way it used to happen traditionally, assuming that in this particular table you want to go ahead and get a sum of salaries of all these employees. That is what we need to do. And it is a 1 GB file with millions of records. So now you may write a code in Visual Basic, Java, or Python. Now, traditionally what used to happen is whenever you want to process the data, the code is there in one particular system. We used to transfer the data or move the data from a system where the data is there to a where the code is there. In a way, the data is fed into a program or a code, and code or a program processes the data and produces the results. That is how the traditional way of data processing. But now, problem here is in our case, we have the data which is distributed. It is not at one place because we have split that 1 GB of data into multiple systems. In this case, where the data is distributed, how do we proceed with the distributed processing? Assuming that your code to calculate the sum of the employee salaries is there in this particular system. What may be the size of the code? It may be not more than MB, right? Whatever, especially in this case, it's not even more than KB. Now, If I ask you a question, is it better to move the data to the code the way we have done in the previous slide, or is it better to move the code to the data? Please pause the video and think what would be the better way in terms of utilization of resources and also in terms of time taken, whether to move the data from all these three systems into a machine where the code is there, or moving the code where the data is there. Please pause the video and just think about it. I think you guys got the answer. We have a data here in these three cases. When we move the data from here to here, it will take more time. But when we move the code to where the data is there, for example, here, here, and here, this takes less time as compared to moving this data to here, this data to here, this data to here. I hope it is making sense, isn't it? So we are moving the code to where the data is there instead of moving the data to code. So we learned it is less resource consuming and also it is less time consuming when you move the code to the data rather than moving the data to the code. So this is also called as distributed processing. Even it is called as a parallel processing, because when you move the code to the data, this code has to act on this, it has to process the data. All these three codes will start performing the processing at the same time. That is the reason it is also called as a parallel processing. Since we are moving the code to the data, it is called as computations to the data. We are taking the computations to the data. And since we are moving the code where the data is there, it is also called as a data locality. It is also called as distributed processing, parallel processing, computations to the data, and also data locality. So this is distributed processing. We learned both the distributed storage and distributed processing. Distributed storage is breaking the big chunk of data into smaller pieces and moving the data into the different systems, that is distributed storage. Distributed processing is taking this code to where the data is there. It is also called as parallel processing. It is also called as computations to the data. It is also called as data locality. Thank you.